Hello, I'm Mr. Wilson, and this is episode 5 in the video series Ethical Hacking. In the previous video, I showed you how you can use code injection to insert code into a text box. When that information is sent to the server will actually execute your code instead of treating it like regular text. I also showed you how to prevent that from happening by using code sanitizing techniques. In this episode, we'll be hacking the database itself by injecting SQL statements, and I'll show you how to sanitize that sort of code as well. Here we are in our file manager, and let's go ahead and talk about the login page itself. So here on the index PHP, this is where you type in your username and password, and it sends that information to the login handler. Let's go ahead and open the login handler to see how that works. Right here you can see that we've got an SQL statement that we're using to process the username and password information that you type into the text boxes. It says select everything from the users table where the username equals whatever it is you typed in the box and the password equals whatever it is you typed in the box. This is our intended statement. When we replace the variables with what we actually type in, then we should get something that looks like this. I'm just going to go ahead and open a notepad program so I can give you a little visual aid here. So this is our SQL statement that we want to build. It's going to look like this when it's all done. And it's going to replace these two variables with what we actually type in the boxes. So for example, if I typed in foo as my username, that would go in here. And if I typed in bar as my password, that would go in right here. And this is the SQL statement that we're hoping to assemble. However, it is possible that we could type in some SQL commands into the username box to overwrite this intended behavior. Here's what that would look like. We'd obviously have to keep the same first part of the SQL statement, so I'll go ahead and type that down here. But what we're going to do is type in something new into the username box that will change everything that comes after this. What we're going to do is type in an asterisk for our username. And then we'll also put in the closing quotation mark, single quote. What this does is this says select everything from the database where the username equals anything at all. And asterisk in SQL means everything. So it's going to select all users from the users table. Well, what about the rest of this statement? It's still going to have this other stuff. So what we'll do is we're actually going to just comment that out. You know that in PHP, JavaScript, and many other languages that if I were to put 2 upslashes in front of this, that would comment out everything else. And essentially the computer would just ignore it at that point, like it doesn't exist anymore. Well, in SQL, it's not 2 forward slashes. It's actually the octothorpe character. You might know that as the hashtag. If I use that symbol instead, that will essentially comment out everything that comes after it, and it will just get ignored by the computer. So let's go ahead and see what that would look like. So I've already typed in asterisk and then a closing quotation mark to close my username field. And at that point, I'm just going to put a semicolon because the semicolon tells the computer that I'm now done with my SQL statement. And then I'll put in that hashtag there to comment everything else out. To ensure that this always returns some type of value, I can actually add a little bit extra. I can add an OR command here. I could say OR 1 equals 1. You know that 1 equals 1 is a true statement. Therefore, regardless of what happens here, this statement is always going to return something because 1 does equal 1. So by putting in username equals anything or 1 equals 1, I can ensure that this SQL statement will always return a value. So let's go ahead and inject this into our code and see what it does. I'm going to go to the login page and I'm going to put our SQL statement that we formed here, the asterisk. I'm going to close the little tag, my or 1 equals 1, the semicolon to end my SQL statement, and the hashtag to comment everything else out. It doesn't even matter what I put in the password box, because the password stuff, if I look back here on this page, the password stuff comes after my username box. So it doesn't matter what I put into the password, because that's going to get commented out. So here we go. Let's type in our little magical SQL injection code, ignore the password box, press the button, and you can see that it will still let me into the page. So now this is an interesting thing that has happened here. We typed in code into our username box. We didn't even type in a password at all, and when we hit the button, the website let us into the page. We did not use a valid username, we did not use a valid password, and yet the server still let us into our page because we actually overwrote the SQL statement that was supposed to be the gatekeeper to prevent unauthorized access. There's one more thing that's particularly interesting here. Take a look at this. Remember that our little page here, the way this is set up, is that if we are a valid user, what it's going to do is display a little message. It's going to loop through all of the records. It was expecting to return only one record, and it's going to say hello, and then it's going to print my first name. Well, because we have reprogrammed this using our little thing to return all right here, return all usernames. Look what it's actually done. If I go back to our page, it says, hello, Bob. Hello, Sammy. Hello, Michael. Hello, and this is the code that we injected in the last episode. But the point is that it is returning a hello message for every single user in our database. So that is a big security risk. Not only did we get into the website without using a valid username or password, we also gained access to information regarding every single user in the database. So this is a big security risk that we have to plug. As we learned yesterday, we can use this HTML Specialchars to sanitize input from the user. We're going to do something similar to sanitize input that goes into the database as well. It turns out there are a variety of tools like this HTML Specialchars, which are designed for sanitizing all sorts of different kinds of code injections. Let's take a look at one of these special sanitizing functions. Here you can see we're building a string of code, an SQL command in this case, and we're inserting information from the user's input, their username and their password. When you do something like this, when you're starting with a string and then inserting user-defined information, there's a special command that will help us with that called sprintf. The way this works is in parentheses, you start writing the string portion of your command that you're building. So maybe it's something like this. Your name is, and then next to that, I want to print whatever their name is. And perhaps there's a text box. They type in the text box, Mike. They hit the submit button. And now I'm going to take what they typed in that text box and insert it into my string. So perhaps this is where I used a variable over here, like maybe I had a variable called my name. So here, this would build a string. It says, your name is my name. But there's nothing to prevent the user from entering something unexpected, something other than a name, like code or numbers or who knows what else. So what sprintf does is this helps us filter user input by only allowing certain kinds of input. Here's how this works. I put a %, and then I use a code character. If I'm expecting a string, that is text, then I would use an S. If I'm expecting them to enter a number, then I'd use a U. And depending on what type of information it is that I'm expecting them to enter there, I use a different code. So the question is, what are those special codes? So here, if you just Google PHP sprintf, you'll get the documentation for this command. And right down here in the middle, it gives you a list of all of the special codes. The most common ones that I use is the S. This is treated as a string. I use U a lot. The argument is treated as an integer and presented as an unsigned decimal number. So you can use any of these codes depending on what type of information it is that you're expecting the user to enter. And what this does is this forces the user to enter the type of information you were expecting. If I was expecting a number, this will prevent them from entering text. In this case, I'm expecting text, so I'm going to force them to give me a string of text. So now, if my original information was stored in a variable like uname or myname or p-word or something like that, how do I tell it what to actually replace this S character with? The answer is you put a comma and then you type in the variable name of the thing that contains that's supposed to contain your string. For example, let's say that I had a variable called my name. So what the computer is going to do is it's going to take the information from my name and it's going to put it in here, only if it's a string. Maybe I wanted to build my string some more and say your age is, and this time I'm going to be expecting a number, so I'm going to use the %sign and a U. So now I've got two variables I'm expecting. One is a string and one is a number. So here, after I built up my string here, I've got my first one is going to be a string, and the second one is perhaps stored in a variable called my age. So this first one corresponds to the first code letter, and this second variable corresponds to the second code letter. This one has to be a string, and this one has to be a number. If you try to type in code, text and stuff into this my age box, sprintf is not going to let you do that. So we can use sprintf to ensure that the proper type of information is being inserted. Let's go ahead and rewrite some of our code in here to take advantage of this sprintf command. All right, we know that our username is stored in this variable and our password is stored in this variable. Let's go ahead and take these variables out and replace them with the special codes for the sprintf. Since they're both strings, I'm going to put an S here, and I'll go ahead and put an S in this one as well. Now I do have to tell the computer that I'm going to be using the sprintf command, so let's put that up at the front. And I'm going to wrap this entire string inside of these parentheses. From the opening quote here all the way to the closing quote right there. Now don't forget you have to put in the little variables to tell the computer what to put in these things. So I'm going to put a comma. And my first one is going to be the uname. And the second one is going to be the p-word. All right, so let's read this. Here I am going to put in an S, and here I'm going to put in another S, a string and another string. The first string is coming from the first variable. The second string is coming from the second variable, and you can add as many of these as you need depending on how complex your SQL statement is. I'm going to be adding some additional code sanitizing techniques in here. So this line of code is actually going to start getting really long. So remember, it's the semicolon that tells the computer where the end of the line is, which means that I can break this line of code anywhere I want, as many times as I want to span multiple lines, make it a little easier to read. So what I'm going to do is I'm just going to actually press enter here, and I'm going to press enter here as well to move those down to separate lines. And then this is the parenthesis that closes the parenthesis I opened here. So these two lines of code are actually this is all just one line of code, even though I've pressed enter a few times. All right, so the first string is corresponding to this first variable, and the second string is corresponding to this second variable. So what other code sanitizing techniques do we have available? There's one called HTML entities, which works very similarly to this HTML special chars that we were playing with yesterday. Let's go ahead and use that. So what this does is it's going to take all common HTML, it's going to look for common HTML things like angle brackets and stuff like that, and it's going to convert those into their HTML equivalents. Here's how it works. HTML, and in parentheses you just put the thing that you want to search. So like, is there any HTML stuff in here? If it finds any, it's going to filter that out. I'll go ahead and do the same thing down here. There's also a command called add slashes. What this is going to do is it's going to essentially comment out or escape any special characters that are commonly used in coding. So I just go ahead and wrap that in parentheses as well. Add slashes to the username. We'll do the same thing down here. Now there's one more command it takes an extra parameter. So I just want to show you how this is going to work. It's called mysqli real escape string. Now this command is designed specifically to look for SQL code, and it's going to strip that stuff out. This one requires two parameters. The first parameter is the connection to the database. So for our purposes, our connection is always stored in this variable called con. And then the second parameter is the thing that you are sanitizing. So this could be like the uname or whatever. Now what we're going to be sanitizing is this stuff up here that we've already started to sanitize. We've already stripped out the HTML. We've already commented out and escaped common code characters. So we're going to take all of this, and that's what's going to be our second parameter. So let's go ahead and start doing that. So we're going to start off with the real escape string command, and then a parenthesis, and then we put in our connection to the database, and the second parameter is all of this stuff that we've already written. And now don't forget, because we have opened a parenthesis here, we must also close that parenthesis over here. And we're going to do the same thing for this password as well. Don't forget to close your parenthesis. All right, now what this has done is this is going to be quite effective at trashing any code that the user tries to inject. It's going to look for HTML stuff. It's going to escape common characters like quotation marks and single quotes and stuff. And then it's going to look for specific SQL commands, and it's going to just rip all of that code apart. Let's go ahead and save that. We're going to go back to the login page one more time. We're going to try once again injecting that same magic code that we did before, but look, there's quotation marks in here. Those are going to get escaped out. The or command is an SQL statement. It's going to get filtered out. So is the hashtag. That's an SQL thing, so it's going to get filtered out. There's no HTML in here, so HTML entities isn't going to do anything, but if there were something, that would get filtered out as well. Let's go ahead and run it and see what happens. Here you can see I just get redirected back to the login page because that was not a valid username or password. So this was very effective at trashing my injected code and ensuring that that code doesn't modify the behavior of my originally intended SQL command. Now let's talk about the registration page itself. Let's go to the register handler. So when we actually first create the username and password for our account, we are inserting that username and password, first name and last name information directly into our database. This is an opportunity for a hacker to inject code directly into our database. So we would want to ensure that we are doing the same sanitizing stuff anytime the user inserts anything into any text box. You want to make sure that you are sanitizing what they type in. If you forget one box, that one box opens you up to a potential hack. There are lots of websites out there where the whole point is to enter code. For example, if you are a programmer and you're trying to figure out how to do something, So you Google it and a website pops up. There are lots of websites out there where the whole intent is to write code. There's lots of forums, for example, where a user asks a question, how do I do this thing? And so other users will respond and say, oh, that command is this, that, and they start writing code. So how do we allow code to go into the database so that it can be displayed in a form, but not actually run that code? So the answer is that you can use something, it's the exact opposite of what we just did, HTML entity decode and strip slashes. So what those do is you can encode and add slashes to anything that you're putting into the database to make sure that it's safe and sanitized. But then when it comes time to actually display that information, you would use decode and strip slashes to remove all of the sanitized stuff so that the code actually displays as text the way it was intended without actually running as code. So just keep that in mind if you need to remove the sanitizing elements. All right, so what we're going to talk about next is a content security policy. There's always someone out there who's smarter than you. There's always someone that knows how to hack things in a way that you haven't anticipated. So is there a way that we can tell the server, hey server, I'm the programmer, only run code that I have written. If code comes from any other source, don't run that. Yes, that's what a content security policy is, and that's what we're going to be talking about next. There are some rules to keep in mind. For example, inline CSS and inline JavaScript is notoriously prone to code injection. As a result, a content security policy won't allow you to have inline JavaScript or CSS. You can still use JavaScript and CSS, it's just that those things have to be stored in an external file. So that's your first rule to note, is that if you want to include any JavaScript or CSS, it has to be in an external file. Now the example that we're going to be running through is kind of complicated because it has all these extra CSS and JavaScript files. So what I'm going to do is in the video description, I'm going to put a link to these code examples so you can copy and paste the code in to make it a little bit easier for you to play with this. Let's go ahead and get started. Here I am in my file manager program. I've cleared out all of our old files just to make things a little bit more clear since there are going to be so many different things going on in this example. The first thing we're going to do is create our first page. I'm going to hit new file here and I'm going to call this csp.html. Let's go ahead and open it up and we'll start with the usual stuff. All right, the first thing we're going to do is tell the computer what the name of our external JavaScript file is going to be. So right here, I'm going to include a file called csp.js. We haven't created it yet, but we will, and that will allow us to access those JavaScript functions. Our next one is going to be a link to the CSS file. So here we'll eventually create a file called csp.css. We'll include that in our page as well. The last thing we're going to do is this example is going to use something called Ajax, and that requires a library which is hosted by Google. And so I'm going to include a link to the Ajax library hosted on the Google server. Okay, so what is Ajax? All of our examples so far, that we would enter in information in a text box, we'd hit the submit button. The computer would then take us to an entirely different page, the handler page, and our results would get displayed there. As a result, anytime we hit a submit button, that caused a page refresh. That's kind of an old way of doing things. Most modern websites don't do that anymore. Think, for example, of Facebook. Let's say that you're looking at a post that someone has written, and now someone has just entered in a new comment. You don't have to hit the refresh button to see the newest comments. They just sort of magically appear. So what is going on there? So in the background, the server is running code like a handler or something. And when it sees that something new has appeared, JavaScript is going to actually insert an element and then put that new comment in there. And if another one pops in, it'll insert another area and put in that comment as well. And it can do this as many times as it needs to. And that's what our page is going to do. This example that we're building, it's going to have a little text box and just say, what is your name? So you type in Mike, you hit the button. The page is not going to refresh. It's not going to take us to a handler. It's going to send our name to the handler. The server will process that and the handler will send back a response. Our page will never refresh. It will simply add an element and stick that response into that element. Let me show you how that works. So the first thing we're going to need to do is put in that element that our response will get added to. So here what I'm going to do is simply use just a paragraph element, a P. I'll give it a name. It's called my P. And you can see that there's nothing in here right now. It's just empty. So what will happen is when I receive the response back from my handler, whatever text the handler returns to me will get put into this P element right here. But for right now, it's empty. All right, and now I need a form that I will use to actually submit my name. So here you've got a form. It's got an ID called Form 1. It's got a name called Form 1, and one input box. It says enter your name. It's a standard text box, and I'm just calling it test is the name of the box. I do have an input button, a submit button, but there's something interesting here. If you take a look, you'll notice that there is no action for this form. So the computer doesn't know where to send this information. What is the name of the handler page? I haven't specified that here. Let's go ahead and save this. And now let's build our next piece of this. I'm going to add a new file, and the next piece is going to be the JavaScript file. csp.js JavaScript file. All right, so remember that submit button? It doesn't know where to send the information to. What we're going to do is we're going to use JavaScript to add an event handler to that button. It's going to listen for a click event. When I click on that button, instead of submitting it as it normally would, it's instead going to fire a JavaScript function, which we'll write in just a moment. So let's go ahead and add that event handler. Here's how we'll do it. We're going to create an onload function. So here, when the page first loads, this function will fire. And what this is going to do is this is going to get the element, the submit button element, and it's going to add an event listener to it. It's specifically going to listen for click events. And when it sees that click event, it's going to fire a JavaScript function called Ajax submit form. We haven't created that yet. That's what we're going to create next. So let's go ahead and move that down and create the Ajax submit form function. Ajax submit form. All right, so what's going to go in this is kind of crazy and complicated. We haven't seen anything quite like this before. This is Ajax code. I don't want to get into a tremendous amount of detail on how this works, but I will give you the gist of it. So here, the first parameter tells the computer how we're going to be sending this form information to the handler. We're going to send it via post. We're going to wait for a response from the handler. We'll wait up to 15 seconds. This is where we tell the computer where we're sending the information. Remember, the form didn't have an action attribute, therefore it doesn't know where to send it. So this is where we're specifying it. We're going to send it to a file called csphandler.php. Okay, I'm sending information to the handler. What information am I sending? This is where I tell it where the information's coming from. It's coming from that object called form1. If I don't get information back within 15 seconds or there's some kind of other error, this function down here will run. This is our error function. Right now I haven't written any code in there, but you could write a little message or something in there if you wanted to. What happens if it works correctly then? In that case, I'm going to run the success function, and that's what this is here. So if the handler does return successful information, what is going to happen? I'm going to go to the document, and I'm going to get an element by its ID. Which element am I going to get? I'm going to get that paragraph tag, that myP element, and I'm going to insert some information into its HTML. I'm going to insert whatever the response was from the handler page. Whatever information the handler returns, I am going to take that response and put it in the P element. Let's go ahead and save this. Okay, so now JavaScript is going to send something to a handler. Let's build the handler next. New file. CSP handler .php. By now we've created several PHP handlers, so this is becoming a little bit more familiar. I'm going to go ahead and add my PHP block. And here's what we're going to do. We're simply going to, when the user types in their name, we're simply, like if they type in Mike, our page is just going to say hello and then their name, hello Mike. So let's go ahead and echo out the hello part of our message and then a space, and next to that I'm going to type their name. So that's the next part. First of all, we're going to check. We're going to ensure that they have actually typed in something into the text box. So we're going to say if this thing is set, what thing? What is it that we're looking at? We're going to go to the post array, and we're going to look at, remember what I named that text box that they're typing their name into? I named it test. So I'm going to look for that test box. And if it is set, if they did type something into it, I've already printed the hello part, so now I'm going to print whatever it is that they typed in the box. I'm going to echo out. All right, I will echo out whatever it is that they typed in the box. And then maybe just, we'll add one little extra bit here. We'll add an exclamation point so that they know that we are extra glad to see them. It's going to say, hello, Mike, exclamation point. And that's it. That's all our handler is going to do. Is it's just going to create that sentence and return that result. All right, you'll recall that our HTML page also had an external CSS file. So let's go ahead and create the CSS file as well. We'll just also call this CSP. This one is a CSS file, so we'll add that. Now, you would obviously create a lot of CSS stuff to make your page look all fancy and whatnot, but this isn't really a lesson on design. So I'm going to just include just one command. And this is all it's going to do. It's going to say, hey, the text box that we're typing our name into, set its width to be big enough for us to be able to see what we're doing. I'm going to make it 500 pixels wide. And that's it. That's all the CSS my page is going to have. That'll give me a nice big box that I'll be able to inject code into. And all right, let's go ahead and test this out. The name of my page is csp.html. So let's go to our page here, /csp.html. All right, so I'm going to go ahead and type in my name and hit the submit button, but I see that nothing is happening. So what I'm going to do is inspect this and go to the console, and I see that I've got an error. It says that it failed to load the resource 404. That means that the file wasn't found, and over here it tells me specifically the CSP handler wasn't found. CSP handler. If I go to my file manager, I can see it's right here, and it looks like it's spelled the right way, but look at my console. It's actually expecting it to be spelled capital CSP, and in my file manager I noticed that it's lowercase CSP. So let's go ahead and rename that. Capital CSP handler, rename, and we'll test it out one more time. Close this and hit submit. Ah, there, now it's working. Okay, so this is what we're supposed to see. Notice that I'm still on the CSP HTML page. It did not go to the handler page. There was no refresh that took place. That invisible P element up there, it simply took the response from my handler page and added that to the P element. So it says hello, whatever I typed in the box, and then an exclamation point. Now, right now, we have not added a content security policy, and we have not added any sanitizing techniques either, which means that this is susceptible to hacking. So what I'm going to do is I'm actually going to inject some code. Let's take a look. All right, so what I'm going to do is I'm going to create a div element on this page, and I'm going to give it an on-click event. When you click on this thing, it's going to run a function. What's the function going to do? This is JavaScript. It's going to run an alert box that says you just got hacked. Luckily, it's not actually going to do anything other than display that message. And I'm going to be clicking on something. So what is it that it's going to be clicking on? I'm going to just write the words "click me" inside of this div. Let's go ahead and test that out. I submit this and it says, hello, click me, exclamation point. Oh, that's weird. It says click me. Let's go ahead and click it. Oh, look, my JavaScript just ran and it says you got hacked. So I did actually quite a bit with this injection. One, I injected an entirely new HTML element, in this case, a div. I told it to run a JavaScript function in response to user action, and then I ran my JavaScript. So this is a very dangerous indeed. Lots of stuff was happening in this one. You know from the previous video that this would be a simple fix. We could just use our sanitizing techniques to fix that. But let's use the CSP, the content security policy, instead. I'm not going to sanitize this at all. I'm going to rely on my CSP to secure this for me. Now, in reality, you would want to do a combination of both. You would want to both sanitize and use the CSP. But let's go ahead and secure this. Here's how we'll do this. We're going to go into our CSP HTML page. We're going to open it for editing, and we're going to add something at the top of our code in the head. We're going to add our CSP. First of all, this is a long line of code. You can see it's spanning 2 lines here, but here's how you read this. The script src right here, this property tells the page where JavaScript is allowed to come from. In this case, it can run code on itself. So the code that's already included here, that external JavaScript file, that is okay. It can also run code from a trusted source. Remember, our Ajax used a Google library, so I have to tell it that that's okay too. So I'm using an external library. It can run JavaScript from that. And basically what the content security policy is it's a whitelist. We get to say where code is allowed to come from. It can come from the code that I have written from myself, and it can come from the Google Ajax library, and that's it. If code comes from any other source, like from a text box, that is going to violate the security policy, and it will throw an error in the console. Let's go ahead and save this. All right, let's go ahead and run this and test it out. Now, this is interesting. There's a link here to our hosting service. I don't know if you noticed this. Let me temporarily remove the CSP here real quick. I want to pull this out. Just going to cut that out and save it. And let's go refresh our page one more time. I don't know if you noticed in the lower right-hand corner, there was this little message about, hey, this website's powered by 000 web host. That is coming from someplace else. That is external code that we did not whitelist in our CSP. So what that means is that when I add my CSP back in here and refresh the page, this thing is going to get blocked. Watch, I refresh it. It's gone, and instead it just gets printed as plain text here, just a plain HTML link. Now, when I try to inject my code, my secret nefarious code in here again, I run it. It's still going to do it's going to add the div and stuff because here we can inspect it and see what it looks like. It still adds the div. It tries to inject all the code. It's got the on-click, it's got the JavaScript and stuff, but what the CSP is going to do is it's actually going to prevent that code from running. That's the difference here. So when I click on this, notice my alert box doesn't appear. So even though the code has been injected, the CSP is preventing it from running. And that's what we see here with our little web host tag as well. The HTML still gets displayed, but all of the other stuff like the CSS and whatnot that made it look pretty, all of that is getting filtered out. So no external CSS is allowed to run, no external JavaScript is allowed to run, only the code that I write and include in my file manager. This is the only code that can run. So you can see how the CSP has got our back. So there are a lot of other functions that you can, if I open up my CSP here again, here, this is where we're telling it what to whitelist, the following scripts, everything from myself and everything from the Ajax library. There are other directives that you can include in this. And in the file that I've linked in the description with these code samples, I've included this page as well to show you what the other parameters for your CSP are. This allows you to really dial it in and get it to work just the way that you want. So the CSP should be used in conjunction with our regular code sanitizing techniques, because you can see the code was still injected. It's just the CSP isn't letting it run. So you want to do a combination of both, where you're filtering out the HTML, you're filtering out all of the stuff, and then the CSP just cleans up anything that you may have forgotten.